Welcome to the deep dive. You sent us some really compelling material on a cornerstone of aviation safety, human factors, both in maintenance and accident investigation.
Yeah, it's a huge topic.
And when we talk about human factors, we're basically looking at how people with all our, skills and our limitations interact with the systems, the procedures, everything involved in keeping planes flying safely.
Exactly. It pulls from so many areas too. Psychology, engineering,
It
ergonomics.
really is multidisciplinary.
And it's just so vital because, as that FAA safety document points out pretty clearly, most incidents, most accidents, they aren't down to the plane itself breaking.
Right. It's usually some kind of human error somewhere along the line.
Precisely.
Yeah.
So the big question is, how do we design the work, the environment, the systems, and maintenance to kind of minimize those inevitable human slips? That's really what human factor is trying to address.
Okay. And to help us sort of get our heads around this, we've got two main sources today. First, that FAA document, Human Factors FAA Safety.
That gives us the principles and how they're applied in maintenance.
And second, the Manual of Aircraft Accident and Incident Investigation from Skybrary.
Which really drives home how crucial understanding these human factors is when, things unfortunately go wrong and we need to figure out why.
Right. So for you, our listener, who brought this fascinating stuff to us, our mission today is to really dig into the key insights. How human factors are essential for prevention through good maintenance and for understanding through investigation.
Okay, so maybe the best place to start is looking at how we even got here. Our understanding of human factors, it wasn't like a sudden discovery. It's really evolved over time.
That sounds like a good way to frame it. It seems like initially the focus was all on the pilots.
Yeah, pretty much. Pilots first, then eventually aircraft design itself came into the picture more.
So how far back are we talking?
Well, if you go way back, before World War I, the approach to making sure people and machines work together was largely trial and error.
Just see if it works.
Kind of. If someone could figure out the equipment, great. If not, maybe they weren't cut out for it. A bit sink or swim.
Wow. Sounds inefficient.
Yeah.
And maybe dangerous.
It definitely was. But, even before that, there were hints. The American Civil War, surprisingly, raised some early questions about, mass-produced uniforms and whether the average soldier could actually use the new weapons effectively.
Huh. Not aviation, but still thinking about the user.
Exactly. It was an early nudge towards thinking about human capabilities when designing things for lots of people. The key idea starting to emerge was that technology needs to work for the people using it.
Interesting. So when did aviation really start looking at this formally?
World War I was a big catalyst. You suddenly had much more complex aircraft, new technology.
Right.
And it became obvious pretty quickly that people struggling to operate this stuff was a major bottleneck. That really kicked off more interest in understanding human limits, human capabilities in the cockpit. Aviation psychology started shifting from just picking the right pilots to thinking about the design, the layout of controls, displays, how altitude affects performance, things like that.
So not just the person, but the person and the machine together.
Precisely. The key takeaway was skilled people aren't enough if the tech itself isn't designed with them in mind, especially under pressure.
And that's when we see aeromedical research really starting up, understanding the physical and psychological side.
Exactly. The U.S. even set up dedicated aeronautical labs by the end of WWI, a real commitment to studying it scientifically.
Okay.
Then, after World War II, the shift became even clearer. It wasn't just selecting people for jobs anymore. It was about designing the equipment itself, thinking about human limits from the get-go.
Proactive design.
Yeah, like that classic 1947 study by Fitz and Jones. They looked at the best way to configure control knobs in cockpits.
Knobs. Seems small.
But incredibly important. Their research showed how the shape and placement of knobs could drastically affect errors. And those findings went way beyond planes, influencing all sorts of designs to be more user-friendly.
Makes sense. Good design is intuitive design, less error-prone.
Absolutely. And, we should probably mention some pioneers here. Way before all this, Leonardo da Vinci was looking at anthropometry, human body measurements, for his flying machine ideas.
I think I saw those sketches in the FAA document.
Yeah, figures 14.6, 14:7, early days, but already thinking about the human form. Then Frank and Lillian Gilbreth, early 1900s, their work on fatigue was huge.
Time and motion studies.
Right, not just aviation, but fundamental insights into how tiredness affects performance, efficiency, safety, very relevant to maintenance techs working long shifts.
Definitely.
And the Wright brothers. They deliberately designed their plane to be a bit unstable.
Really? Why?
They called it cerebralized control. Inspired by birds, they thought it gave the pilot more direct, almost intuitive command, rather than relying on the plane just staying stable by itself. And between 1901 and 1903, they developed the first really practical controls for pitch, roll, yaw. Plus, engine power control in flight, an early angle of attack sensor, even a stick pusher to help the pilot.
They thought of all that back then.
Oh, yeah. Orville used a seatbelt. They had a basic rudder boost trim system. They even built their own flight simulator for training. A lot of concepts in their early patents are still around today.
That's incredible. They were really early human factors engineers, weren't they? Even without the label.
You could definitely say that, thinking about how the human interacts with the machine right from the start.
Okay, so we've seen this evolution pilot, then design, then a broader view. What fields actually feed into human factors today? It sounds like a real mix.
Oh, it absolutely is. Highly multidisciplinary. That figure 14:5 in the FAA doc gives a good visual. You've got cognitive science.
Understanding how we think.
Exactly. Especially under stress. Think about an aircraft maintenance technician, an AMT, troubleshooting a complex problem with a clock ticking.
Yeah, that's high pressure. You need to think clearly.
Right. So cognitive science helps design tools, procedures, training to support their mental processes, prevent overload, reduce errors. Then there's medical science.
Physical health, fatigue, how people differ physiologically.
Yep. How all that affects performance, reactions, stress levels, and organizational psychology that's crucial.
How people work together, the workplace itself.
Yeah, relationships between people and work. Structure, job satisfaction, teams, training, selection. It all impacts the maintenance environment, productivity, and safety. A healthy, supported workforce is just safer.
Makes perfect sense. A good work environment must prevent a lot of issues.
Definitely, and the list keeps going. Educational psychology. How do we design effective training for AMTs? Safety engineering, designing safe systems, minimizing risks.
Okay.
Computer science is huge now with all the digital tools, electronic records, complex interfaces in modern maintenance.
True.
Anthropometric science, back to Da Vinci, measuring people to design tools, workspaces ergonomically. Experimental psychology gives us the research methods to study behavior, gather evidence. Even clinical psychology plays a role, helping understand and manage stress, anxiety, fatigue that impact performance in these critical jobs.
It's amazing how many different angles you need to cover the human element.
It really is complex.
Now, the FAA document also mentioned something called the PE model. Can you break that down? Sounds like a useful framework.
Yeah, PE is really helpful for thinking about the key parts of a maintenance human factors program. It stands for people, environment, actions, and resources.
Okay, PER. Let's start with people.
So people covers everyone involved. You look at their physical abilities, physiological state, like are they tired, are they healthy, psychological factors, stress, morale, even psychosocial stuff like teamwork, communication.
So the whole person.
Right. Recognizing differences, matching people to tasks, fostering health, addressing issues like substance use, making sure teams communicate well. The core idea is that performance depends on a whole range of individual factors.
Got it. Recognizing and supporting the individual within the system. What about E for environment?
Environment has two sides. There's the physical workplace temperature, light, noise, cleanliness, how the space is laid out.
The hangar conditions, basically.
Yeah. And then there's the organizational environment. Staffing levels, supervision quality, labor relations, time pressures, crew structures, company culture, morale, even company size and finances. Figure 1412 shows some of this.
So both the physical space and the kind of company atmosphere.
Exactly. The conditions people work under massively impact safety and effectiveness. A noisy, dim hangar or a high-pressure, blame-focused company culture. Both increase risk.
Makes total sense. The FAA doc even mentioned companies providing heaters or coolers, right? Practical stuff.
Yeah, it shows corporate commitment matters. Okay, then A is for actions.
The actual tasks being done?
Yep. The steps, the sequence, how many people are involved, how information is controlled, the knowledge and skills needed, certifications, inspection steps. Figure 1413 gives examples. It's about how the work itself is structured and performed.
So the process needs to be clear and make sense.
Exactly. And finally, R is for resources. Everything people need to do the job right.
Tools, manuals.
Tools, manuals, procedures, work cards, test equipment, computers, software, paperwork, even access to other knowledgeable people for help. If people don't have the right resources, errors are just more likely.
So if a tech needs a specific calibrated tool and it's not available, that's a breakdown in resources.
Correct. When resources are there, accessible, up-to-date, tasks get done right the first time. Safer, saves time, saves money. Peer shows how all 4 people, environment, actions, resources are linked and need attention.
That's a really clear framework. Okay, the FAA doc also listed the dirty dozen. Sounds ominous. What are these?
Yeah, the name grabs you. There are 12 human factors consistently found to contribute to maintenance errors, kind of like common traps or tendencies that can catch anyone out.
Okay, what's number 1?
Lack of communication, failing to share info, misunderstandings, not listening properly. The advice is basically be aware, communicate clearly, listen actively. It seems basic, but breakdowns here can be catastrophic.
Absolutely fundamental. What else is in the dozen?
Number 2, lack of knowledge. Maybe training wasn't enough, procedures weren't updated, or it's just an unfamiliar task. Then, distraction. Any interruption that breaks concentration.
Easy to see how that leads to missing a step.
For sure. Number 4, lack of teamwork. Breakdowns in cooperation, coordination, supporting each other. Maintenance is often a team game, and if the team isn't clicking, errors creep in.
Everyone needs to be working together, looking out for each other.
Exactly. Next is fatigue. Huge impact on attention, decisions, awareness. The doc mentions managing shift work, referencing regulations like 14 CFR Part 121.
Like the rules for pilot rest?
Similar idea. Managing duty times. And basic stuff helps too. Sleep, diet, exercise. And crucially, don't tackle complex safety tasks when you know you're wiped out. A tired mind makes mistakes.
We all know that feeling. Hard to function while one exhausted.
Then, lack of resources. Ties straight back to the P-year model. No proper tech docs, wrong tools, can't get info from the flight crew maybe. Figure 1424 points out how useful flight crew input can be. Next, pressure. Tight deadlines, wanting to get the plane back in service, feeling rushed. Efficiency is needed, but pressure should never compromise safety procedures.
That must be a constant tension in the industry. Schedule pressure versus safety.
It really is. Number 8, lack of assertiveness.
Yeah.
Not speaking up when something seems wrong, maybe because of hierarchy or feeling intimidated.
So being afraid to question things.
Yeah. The key is fostering a culture where people can speak up, give feedback, raise concerns without fear. Safety depends on everyone feeling empowered.
Psychological safety, that's
a lot. Absolutely.
Yeah.
Next, stress. Can be physical, working in awkward, tight spaces, or psychological, emotional stuff. Work worries, deadline anxiety.
Both can impact focus.
For sure. Then, lack of awareness. This happens with repetitive tasks. You sort of go on autopilot, lose the bigger picture, miss subtle changes. Figure 1428 mentions this. Stressing the need for checks even on routine jobs. Familiarity can breed. Well, lack of vigilance.
Yeah, you stop really seeing it after the 100th time.
Exactly. Number 11, norms. The unwritten rules. The way we do things around here. Sometimes these norms involve unsafe shortcuts.
And new people just pick them up.
Often, yeah. Figure 1429 highlights this. Supervisors have to ensure everyone follows the approved, safe procedures, not just the accepted ones. We've always done it this way isn't good enough if it's unsafe.
Gotcha. Breaking bad habits. What's the last one?
Complacency. Basically, overconfidence. Even highly skilled people doing familiar tasks can get complacent. The fix. Always get your work checked by someone else qualified, no matter how experienced you are.
So even the best need that second pair of eyes, a safety net.
Exactly. Complacency can affect anyone. The Dirty Dozen really covers the main human pitfalls in maintenance.
It's a really comprehensive list. Okay, let's shift gears now. How do human factors play into what happens after an accident or incident? The Skybrary Manual of Aircraft Accident and Incident Investigation is our guide here.
Yes. And first off, the manual clarifies that accident investigation basically covers incident investigation too, just for simplicity. And the absolute #1 goal of any investigation is prevention. Learning what went wrong to stop it from happening again.
Not about blame, but about understanding the causes to improve safety.
Precisely. The manual talks about the investigation authority, its structure, its responsibilities. It stresses needing strong laws, giving the authority power to investigate independently.
Like getting access to evidence.
Exactly. Immediate, unrestricted access to evidence without needing permission from courts or whoever. Figure I-21 and Section 2.2 cover that. Proper funding is also key, plus experienced, trained personnel. Sections 2.4 and 2.5 go into that. A strong, independent authority is crucial.
So having the right setup, legally and logistically, before anything happens is vital for a good investigation later.
Absolutely. The manual calls it investigation readiness. Having documented policies, plans, procedures, checklists ready to go.
Being prepared.
Right. And it also points out that no single authority has all the expertise for every scenario, especially big, complex accidents. So, Setting up memoranda of understanding MOUs with other countries, other agencies, or specialists is essential.
To share resources and expertise.
Exactly. Appendices 2 to 7 in the manual give examples, MOUs with police, coroners, other aviation authorities. Collaboration is key.
Building that network beforehand. Makes sense.
The manual also covers planning the investigation once it starts, managing the team, liaising with others, media strategy, securing records like the black boxes, planning wreckage removal.
And it all starts with that initial notification, right? That an accident or incident happened?
Yes, Chapter 4 covers that. The responsibilities of the state of occurrence, the country where it happened. And it includes contact info for investigation bodies worldwide, which is vital for international cooperation.
Okay, so notification happens, the team gets mobilized. What are the first things they do at the actual site? And you mentioned environmental hazards being a big deal too.
Oh yeah, absolutely. Initial priorities at the site. Secure it immediately, protect the evidence, start recording everything, photos, sketches, notes on where things are, talk to any eyewitnesses, and do a preliminary look at the wreckage.
Get a first impression.
Right. Then hazards. Section 5.4 covers this. Dangerous goods are a big one. Planes might carry radioactive materials, flammables, corrosives.
Wow.
There are strict procedures, especially for radioactive stuff. Only qualified people handle it. Investigator safety is paramount.
Definitely don't want just anyone messing with hazardous materials.
Absolutely not.
Yeah.
Then there are wreckage hazards, shifting metal, pressurized containers like oxygen bottles or fire extinguishers that could rupture. Even damaged tires can explode.
Unstable environment.
Very. And tragically, if there are fatalities, biological hazards are a concern. Investigators need proper PPE decontamination procedures.
A lot to manage just staying safe. And the environmental hazards.
Chapter 5.5 deals with those. Extreme heat or cold risk of heat stroke, hypothermia. Need precautions, proper gear. Mountainous terrain altitude sickness is a real risk.
Acclimatization needed.
Yep. Deserts mean dehydration risk. Jungles or swamps have their own issues. Animals, insects, difficult terrain. The manual stresses working in pairs, having first aid, reliable communication. The location itself adds huge challenges.
It really drives home that investigations can happen anywhere under incredibly tough conditions. Requires resilience, planning.
Totally.
Okay, the outline also mentioned wreckage recovery, especially underwater, and specialist exams. That sounds extremely complex.
It is. Locating and mapping the wreckage is step one. Underwater, that means listening for the underwater location beacons, ULBs, on the black boxes.
The pingers.
Exactly. They emit ultrasonic pulses. The standard was 37.5 kilohertz, good for maybe 2.5 kilometers range, lasting 30 days. But ICAO mandated changes longer life, 90 days, and new lower frequency 8.8 kilohertz beacons with much better range. Those were supposed to be on planes from 2018.
Had a chance of finding them, especially in deep water.
Right. Figures I-54 to I-57 show some underwater wreckage examples. Technology is key here.
And once located, how do they get it up?
Various ways. Hoists from ships, divers attaching inflatable lift bags, using remotely operated vehicles, ROVs, with robotic arms and baskets for smaller bits.
What's the priority?
Usually the flight recorders first, then critical debris, avionics with memory, and sadly, human remains. The team has to decide what's most crucial to recover based on goals and resources. Sometimes getting as much as possible early is better than disturbing the site multiple times.
Requires specialized gear and careful planning.
Definitely. And once recovered, then comes the detailed specialist examination.
The forensic part.
Pretty much. Examining damaged parts to find the exact failure mode. This can involve scanning electron microscopy for tiny fractures, chemical analysis, testing systems in labs.
Often needs manufacturer facilities.
Often, yes. They have the specific kit and expertise. The investigator's role here is crucial. Provide a detailed history of the part, where it was found, any observations, and ensure it's preserved perfectly during removal and transport. Even tiny details like paint smears can be vital clues.
So meticulous handling and documentation are essential.
Absolutely. Careful packing, labeling everything to prevent further damage or contamination that could mess up the analysis.
It sounds like from the first moment at the site to the final lab report, it demands incredible attention to detail, hazard awareness, and, well, understanding human factors throughout.
Exactly. Human factors aren't just for prevention through good maintenance. They are a critical lens for investigators analyzing the whole event sequence. Understanding the actions, decisions, limitations of everyone involved, maintenance, pilots, ATC, is key to finding the true causes and making effective safety recommendations.
So wrapping up our deep dive today, it's crystal clear that human factors are just fundamental to aviation maintenance safety. It covers everything: the people, the environment, the actions, the resources.
And constantly working on understanding and mitigating those dirty dozen factors isn't a one-off task. It's an ongoing process for the whole industry.
Right. And then, when an accident does happen, that understanding of human factors is absolutely vital for the investigation. It helps unravel that complex interplay of human capabilities and limitations that might have contributed.
And the sheer complexity of some investigations, especially deep underwater recoveries, just highlights the need for international cooperation, solid protocols, and continued technological advancement.
It's been a really insightful and, yeah, sometimes sobering look at this critical area. It makes you think. Considering this really intricate mix of human elements in aviation, a high reliability field, what other high reliability industries, maybe nuclear power or healthcare, complex software development, could really benefit from a similar deep systematic focus on human factors? And how might they actually implement strategies like the ones we've discussed? It's definitely something to ponder. Thanks so much for joining us for this deep dive.